perhaps a bit of a different audience than I might normally talk to. It's generally, predominantly the electrical transmission distribution industry, and maybe a bit of a different focus in that it's focusing on the measurements rather than perhaps what I normally talk about, which is what we do with it. But what I have tried to do is to talk about what we do with the data, with the measurements, with the information, and then to direct, perhaps provide insight in where we need measurements and why we need measurements, and building on that theme of confidence and confidence for investors. Perhaps if there's any wavering investors out there, convince them that yes, we do really need measurements, and they can invest with confidence into the various technologies. So, starting off perhaps with picking up on themes from earlier. Actually, there's a slide which I took out in the end, but I think would have illustrated very well the point that Nick Windsor was making, I think, first, about the big shift of the delivery of energy from gas and from carbon-intensive methods of delivery onto the electricity system, and the big impact that's having on the electricity system itself. And for me, the way round that, or one of the tools that we can bring to assisting with that process, other than massively increasing the size of the networks, we loosely call smart grids. Personally, I hate that term. It's not very descriptive at all. I much prefer to talk about flexible, low-carbon networks. In a UK context. In other parts of the world, smart grids may be for a very different reason. But for the UK, I would argue predominantly flexible low-carbon networks. And so what are the flexibilities that we're trying to apply? The first is long-term. Again, one of the speakers this morning was talking about whether or not we'll get a new fleets of nuclear. So it's trying to put in place the flexibility against different structural effects that we don't know, so we're not wasting the investment that we're putting into the networks. Second, as Alan was talking about, is flexibility against the planning effects. The medium term, the time horizon of 1 or 2 years in terms of do we invest in this substation or don't we invest in that substation. And then the third is the operational flexibility, the variation of load and generation over the course of a day or a week, and how we accommodate that. And so, for me, there are 3 forms of flexibility that smart grids can help to provide. The plant there that you see, or did see on the left, though, is only half the story. There's a whole market side of it that we very rarely see. Well, except for the fact that our energy retailers send us a bill every quarter, and that's our general interaction with the whole market side of the energy system. But nonetheless, it's still there. It's important. It's behind the scenes, and it can bring some of that flexibility. So the 3 areas on the network side, on the real hard wires side, which I suppose generally is the focus for today, given that it's about measurement, is flexibility within the networks, but also flexibility within the generation and flexibility within the demand. And on the market side, and I know there's work going on within Ofgem and Elexon and others to encourage that, but the market has to be right to encourage that flexibility. And then the final piece of the jigsaw, particularly as smart meters keeps popping up today, is and it's inextricably linked as an enabler to this, is the tariffs to encourage flexibility. And I know there's also a drive on making those tariffs simple for consumers, but if we make them too simple, they're not going to deliver that flexibility. So there's a balance to be struck in making them simple for consumers, yet delivering the flexibility that the networks and the other stakeholders within the system need. So what I'm going to do now is look at some low carbon networks fund projects. Low carbon networks fund has been mentioned already today. And often, I think, it's unfortunate, it's often considered, Low Carbon Networks Fund and smart grids are often, the phrase is almost used interchangeably, and it's not really the same thing at all. Low Carbon Networks Fund is about delivering pilot projects that demonstrate how we can make the networks more amenable to delivering low carbon energy. Smart grids is one of the tools to help that. But nonetheless, it's probably the area that there's most work going on in the UK, if not the world, in the area of smart grids. And the Ofgem's fund is very much to be welcomed for that. And what I've got here is a sort of a bit of a crowdsource diagram, if you like, showing where the different projects that have been running to date have applied the different tools that you see at the top into delivering solutions for different parts of the system. So I think much of these tools have been discussed so far this morning, perhaps only loosely. So, for instance, dynamic ratings is about changing how much power you can put through networks according to weather conditions. Energy storage perhaps hasn't come up, but it's a key element within smart grids. Power flow control, again, helping to make best use of the available headroom within networks. Network control itself demands, so the four on the side are less about the real hard equipment and more about how you control the networks. And the one I've sort of deliberately missed off because I'm coming to last is the monitoring and data side. So if I just run these through, the ovals, the size of the overalls gives some indication of the sort of size of the project, the project that aspect of the project. It's not hugely scientific, but gives a good indication of where the interest is. And you'll see in the middle there, the purple is the monitoring and data. And an interesting, while it's not perhaps a huge amount in spend terms of the projects in comparison to the actual things you're doing, it appears in almost every single project because it's just so important within the whole scheme of things. And so if you like, if you can see that our target is low carbon networks and smart grids is one of the enablers to get us there, well, good monitoring, good data is one of the enablers for smart grids. So it's definitely, you could call it the horseshoe in the chain. Another bugbear of mine. A few years ago we had smart grids. The latest term that appears to be coming up is big data, which annoys me intensely. It's not about big data. It's about the right information. It's about and it's come up. I mean, again, Alan mentioned it. He said he wants equipment suppliers not to give him loads of data for him to analyse, but actually to do that analysis within the equipment and give him useful information. And for me, that's what smart grids is about. It's about having useful information in the right place to make the right decisions. So, a few examples. I'm not suggesting that I've covered everything. I definitely haven't. But just a few examples of where information might be useful, might help network operators and others. And I think Nick Windsor's left now, so he perhaps won't be upset that it all focuses on the distribution network and not the transmission network. But one of them, perhaps loss of supply, helping network operators to respond more quickly when consumers are lost. What's happening in the local network close to the consumers in the LV network? What's happening with generation output so that we can respond, or networks can respond to that, and perhaps even a forecast of what's going to happen over the next few hours. Plant condition monitoring has been mentioned. I've highlighted transformers there, but equally on overhead lines. And the last one, network power flows. And then sort of, so picking up on those 5 examples, what are the sorts of measurements, what are maybe the innovations that have come about recently in terms of providing measurements that allow those applications to happen. And actually, Nick might be more pleased now, because phaser measurement units is something that's come about in the last few years, and predominantly has been about the transmission network. It's about making measurements differently, instead of just making voltage and power flow measurements as a magnitude, actually an angular part to that as well, but with a single point of reference. So it requires an accurate time source to be distributed across the whole system to allow everywhere on that network to reference the angle of the voltage or the power flow at each point in time. And that's something that's only been possible of late with the likes of GPS satellite timing and the ability to distribute accurate time sources. And that brings greater abilities in terms of the determination of power flows across the network. Plant condition monitoring, so overhead line temperatures, transformer internal temperatures, for two purposes. One for the purposes of the whole lifetime of the transformer or the plant, whatever it is, to decide when best to maintain it, but also in order to determine how much overhead we actually have. It's not just what overhead, general overhead we have if we've got 20% overhead or 50% overhead, but what overhead do we have now? How much can we increase things now? Lower down the network, cable link box measurements. It's perhaps, it hides a few things there. Essentially, we're talking about a box in the ground that we put some measurements in. And they're not particularly special measurements. They're measuring current, power flow, voltage. But until recently, those sorts of products weren't available. Perhaps there's a cost driver to it. Again, perhaps harping back a bit unfairly to Nick in talking about transmission networks being smart grids. I might say that what we're trying to do is create the same at the distribution level at a fraction of the cost. And there's probably some truth in that, but unless we have the technologies at the right price, it's not going to happen. It's going to be too expensive. A smart grid isn't going to be a more expensive grid. It's going to be doing things in a smarter way at the same cost that we've done them previously. So cable link box measurements as an example of the sorts of instrumentations that are going in there at the lower down in the network. And then finally, smart meters. Smart meters can deliver us some loss of supply information. They can also deliver us some voltage information and some load information that can assist with the operation of the network. But they're not the only source of that information, and it may be that network operators don't need to access that data in order to operate the network, but it's a source of information. Okay, and finally, last slide. Again, it's come up already this morning, this idea of interoperability. Another of the key requirements for smart grids is to have equipment interoperable, so that when you buy from hopefully Siemens and somebody else and plug it together, it is a smart grid. It operates together, and the European Commission recognises this. And so there's a body which has been tasked with helping smart grids to create interoperable systems across Europe. So there's a body called the Smart Grids Coordination Group, which has a number of work streams, and part of this is the Smart Grid Application Model. And the idea of the Smart Grid Application Model is to say, how are we interoperable on a number of different planes? So if we start on the bottom, we've got the component layer and we've got the process stream, if you like, and quite clearly we have to be able to plug the wires into the transformers and connect all the way down the system. There are known ways, there are standards of how you construct equipment to allow that to work together. And it's taking the same process and bubbling it up through the network. As we move away from the actual process itself, if you look at the field in the substation and the operation, there are physical standards there today of how you take IT hardware and you place it there and plug it in and connect it up. But then as we lift up through the planes, we're looking for interoperable standards at different sorts of levels. The most obvious one is the communication level. There are communication standards out there. They're constantly developing, but standards exist. But as you go further up those planes, fewer and fewer standards exist. And part of the work of the Smart Grid Coordination Group is actually to map out what standards exist at different planes, and so where we can identify what's missing and maybe then encourage standards organisations to do something about developing them. So communication layer, information layer, and then there was a question earlier again about smart grids across Europe and what's being done there. And what we're really talking there is the business layer. How are smart grids going to work together across Europe? So what's the business, the commercial drivers to allow them to operate? But that's at the end of my side. Just to summarise there, smart grids need high quality information, not big data. Smart grids will be less expensive than the conventional alternative, otherwise no one's going to build them. Data sources or the measurements themselves need to be easy to retrofit, reliable, Roger, and interoperable. And smart grids implies interoperability at all levels, and especially with measurement sources. Thank you.